Hey guys, this is Rishnada. So today we'll continue with the components of retrieval augmented generation. So the next component we'll be looking into is retriever. So the retriever selects the most relevant chunks. So example, if you ask a question like what is a maternity leave? So the retriever mm, returns the chunks like chunk 8 or chunk 21 or chunk 32. So these chunks go to the large language models. And a part of this is called top K retrieval. So instead of retrieving one chunks, you can retrieve like K number of chunks. So, for example, eh, you can ask for like the top three or top five or top 10. So, the more chunks provide more context, and too many chunks can increase the token usage. Next component is prompt augmentation. The retrieved chunks are inserted into the prompt. So, for example, if you give a context like employees receive 20 days vacation, so and ask a question, so how much vacation leave? So the large language model now answers using the context that you that is given to the large language models. Next component is the large language model. So now the LLM generates the answer. So instead of relying on memory, it uses retrieved documents. So for example, like the retrieved context, it will so once the context is retrieved, that retrieved context will go to the GPT, and then the GPT provides the user with the answer. And the last component is final response. So this is the response that users receive after the retrieval, after the retrieved context is sent to the GPT. So the user receives, like according to employee handbook, the employee receive 20 vacation days annually. So when you ask the question goes to your documents and then the it retrieves the exact answer for the question that you ask, and then it gives the final response. Next is response. Next is types of retrieval. And the first one is dense retrieval. So dense retrieval, it uses embeddings. And for anyone who don't know what embedding is, so uh, embeddings, embedding is a numerical representation of text. So instead of storing words as plain text, they are converted into vectors. So this embedding is used in this embedding is used by the dense retrieval, and that's a semantic dense retrieval gives us like a semantic understanding, and it is the most common in retrieval augmented generation. Next is sparse retrieval. So sparse retrieval uses keywords instead of embeddings. So for example, like BM25 or maybe a traditional BM25 which is also known as the traditional search engine. Next is uh, hybrid retrieval. So a hybrid retrieval combines both the dense and the sparse retrieval, and it provides higher accuracy than both the dense and sparse separated separately. Next is metadata filtering. So each document can contain a metadata. So, for example, the department, this department, HR. So if you give context like department, you give HR department, year you give it as 2025, and then for language you give English. So it's like before retrieval, it's like filtering the metadata. So, for example, if you give department is equal to department as HR, so only HR documents are searched in the filtering. Next is re-ranking. So, retriever may return chunk A, chunk B, or maybe chunk C. A re-ranker reorders them, so it improves the retrieval quality. So popular re-rankers are like Cohere re-ranker, cross encoders, and BGE re-ranker. Next is context window. So large language models have token limits. For examples like 8K or maybe 32K or maybe like 128K. So only retrieved chunks fitting inside the context window or are included. Next is the token budget. So, for example, if you the context is like 3000 tokens and the question takes 100 tokens and the response is 900 tokens. So, the total tokens are like 4000 tokens. So, the prompt must stay within the model's limit. So you can use the less amount of tokens, but the token limit it should not cross the number. Next is hallucination reduction. So since the answer comes from retrieved documents, hallucinations reduce significantly. So instead of just guessing the answers, the model cites retrieved evidence. Next is grounding. So grounding means like the answer is based on retrieved facts instead of just assumptions. So grounded AI is like more trustworthy. Next is sources and citations. So advanced retrieval augmented generation systems also return interfaces. So, for example, if you give a source like employee handbook PDF and you give the specific page like page number 12, so this improves the transparency of the answers. Next is multi-document uh, RAG. So sometimes information exists in multiple files. So, for example, like policy.pdf or salary.pdf or maybe benefits.pdf. So, retriever combines relevant chunks from all documents. Next is conversational RAG. So, the system remembers the previous questions. So, for example, if the user gives a question like, who is the CEO? And the next question includes like how long has he worked there? So the retriever includes chat history. Next is agentic RAG. So an AI agent can perform multiple steps. So for example, it reads the question given by the user, and then it searches the database. It's and it searches the web, and then it search the SQL, and then it combines the information but from different sources that it has found from, and then it is given to the large language models, and then the large language model gives us the answer. So this is more powerful than a traditional RAG because it can reason about where to retrieve information from. Next is graph RAG. So instead of retrieving information only, instead of retrieving only vector similarities, knowledge graphs are used. So, for example, like a person works at a company located in country. So instead of just writing it like one sentence, so you could just like write it in different sentences. So by putting arrows in between. So it's like person and then down arrow and then works at and then down arrow. So it's like a flow chart. And then so it's useful for connected information. Next is multi-model RAG. So RAG isn't limited to text. So it can retrieve images, audio, videos, tables, PDFs, and charts. So for example, a question if the user asks a question like explain this company's sales charts. So the retriever fetches the chart and related text before the LLM answers. The LLM answers the question. Next is RAG evaluation metrics. So to determine whether a retrieval augmented generated system is performing well, several evaluation metrics are used. The first one is retrieval precision. So it measures how many retrieved documents are actually relevant. So high precision means most retrieved chunks are useful. Next is retrieval recall. Retrieval recall measures whether the system successfully retrieved all the relevant documents. So high recall means it did not miss important information. Next is faithfulness. So faithfulness checks whether the generated answer is supported by the retrieved documents. A faithful answer avoids unsupported claims. Next is answer relevance. So answer relevance measures how well the generated response addresses the user's question. Next is context relevance. Relevance evaluates whether the retrieved context is appropriate for answering the query. Next is latency. So latency measures the total response time from receiving the question to generating the answer. And the last one is cost. So cost tracks expenses related to embeddings, vector database operations, and LLM interface. Next is challenges in retrieval augmented generation. So some common challenges include poor document quality, incorrect chunk sizes, low quality embeddings, missing relevant documents, context window limitations, expensive vector searches for a very large database, and duplicate or conflicting information. So, and the advantages of retrieval augmented generation are it uses up to date information without retraining the model. Second point is it reduces hallucinations by grounding responses in retrieved documents. And the third part is it can work with private or maybe proprietary data. Next is it improves factual accuracy. And the last one is it is easier to maintain because updating the knowledge base is often enough. And the disadvantages of retrieval augmented generation are it requires additional infrastructure such as embedding models and vector databases. Next is the retrieval quality directly affects the answer quality. Next is it adds latency compared to calling an LLM alone. And the last point is it requires careful tuning of the chunk size, the overlap, and the retrieval parameters. And the next is the real world applications. So, retrieval augmented generation is used in production systems across industries. So, it's used in customer support, enterprise knowledge assistance, healthcare, legal research, education, and financial services and software development. So, and the popular RAG frameworks and tools include LangChain, Llama Index, Haystack, uh, Semantic Kernel, DSP, and then LangGraph. So, yeah, so that is the end of retrieval augmented generation. So, that's it for today, and I'll see you again tomorrow. So, yeah, thank you all for listening. Bye.